Hello, everybody, and welcome to the second episode of the Switch to Clarity webinar. Today's topic is what's new in ISO 15118-20. And so that you don't have to hear everything from me alone, I've invited some experts from my team and also from Hubject. So let me quickly introduce everyone. For those of you who may not know me, sorry, my name is Marc. I'm the founder and the CEO of Switch. And we also have here André, who is our CTO. So he is the technical wizard in this company who makes sure we are doing our job right with all our products. And we also have... Hi, everyone. Then we also have here Shalin to my left. He is our wizard when it comes to all things EXI related, which is a topic that we will briefly talk about in this webinar as well. And also we have here Adam, who is our Chief Product Officer here at Switch, and he volunteered to help us out a little bit with the moderation of the questions in the end. So thanks a lot for that, Adam.
No worries. Hello, everyone.
And last but not least, we have Steffen Rhinow from Hubject. He's the plugin charge expert at Hubject, and he will tell us a bit more about the effects of -20 on the existing plugin charge ecosystem and implementations. And he will also give us a slight introduction into their new open plugin charge protocol.
Yep.
So all very exciting topics. For those of you who have not yet, let me just focus back. For those of you who have not yet joined us in the previous webinar, let me quickly guide you through how this works in Crowdcast, our webinar platform. On the right-hand side, you see the chat box, and it would be great if you could type in quickly where you are joining us from. I see already a lot of people have commented. We see people from Portugal, from Southwest England, where we are from the Netherlands, Sweden, Michigan, US, Bordeaux in France, Germany, Stockholm, Valencia, Berlin, Ingolstadt, Milan. Wonderful. Cool. When it comes to questions, please do not put the questions in the chat box. We have a specific question box down here. Ask a question, it is called. And everyone has the opportunity to upvote a question that they deem relevant or interesting to them. And in the end, we will then answer all the questions in the last probably 15 minutes of this webinar. And we will start with the ones that have been upvoted the most. And we will also have we have also prepared 2 polls that we would like your opinion on. And I think that's it for the introduction. I would say let's jump right into the slides. So let me share my screen. No, not this one. Right. Oh, sorry for that. Okay. Just a quick confirmation. You guys can see the cover slide or not? Oh, I am. Wait.
You are large.
Right. Still need to get used to this.
Yep, now we can, Marc.
Now you can. Perfect. I put it to presentation mode. All good? I'm still large, right?
All good.
All good?
Yeah,
okay,
all good.
Perfect. So, what's new in ISO 15118? I already introduced all the presenters of today. A very brief introduction to Switch. What do we do? Well, we built the technology behind the seamless charging of electric vehicles. So we have specifically 2 software products. One is an operating system for EV chargers, which we call Joseph, and we have a brief slide on that. And on the other hand side, we also cater towards charging station network operators with our own charging station management system called Sarah. And both Sarah and Joseph are built in-house, and they work perfectly together to really get this seamless EV charging experience that everyone is longing for out into the world. But we're here today to learn more about ISO 15118 and specifically about -20. But before we dive into -20, maybe for those who are not very much accustomed to what ISO 15118 itself is all about, let me tell you the main benefits that I see in ISO 15118. On the one hand side, it is a standard for all kinds of vehicles, be it an electric car, be it a motorbike, be it a truck, a bus, a ship, or even a small airplane. I really have seen a small airplane from, I think, a Slovenian company called Pipistrel that provide electric airplanes. And all of them can be powered with the combined charging system, which is very quickly becoming the dominant standard out there. And ISO 15118 is the software, the communication protocol underlying the combined charging system. Secondly, ISO 15118 introduces the very user-friendly and also attached with a high level of data security identification mechanism called plug and charge. The idea here is that you as an user just plug in your cable into the charging station and the identification authorization is taking place automatically, and the billing process is done automatically in the end without you having to do anything else. No RFID card required, no smartphone app that you have to get out and then scan a QR code or whatever. It's as seamless as possible. That's what plug and charge is all about. Thirdly, strong data security. The e-mobility market is still in a quite nascent state, but we are on the verge of a mass market already. And the more electric vehicles we see on the market connected to a critical infrastructure such as the electricity grid, the more interesting it becomes to hackers. And we don't want hackers to manipulate our charging infrastructure or manipulate the billing process or the billing information for the energy charged. Therefore, ISO 15118 has data security mechanisms in place, such as TLS 1.2, digital certificates, digital signatures, and so on. And last but not least, I want to point out smart charging. So instead of plugging in your vehicle and the vehicle starting to charge with a maximum power available at the charging station instantly, without knowing how much energy the vehicle needs or when the vehicle needs to be fully charged. Instead, you could use smart charging, where we gain or gather all that information from what's the mobility need from the driver, what is the current state in the electricity grid, maybe what is the forecasted availability of renewable energy sources such as wind and solar power, and all that can be accounted. And then you have a smart charging profile for each and every vehicle connected to your charging network. So that's the baseline. ISO 15118-2 was published as a standard back in 2014 already. So it took the car industry around 7 years to pick this standard up. And we are already looking at a new version of -20. Among those most interesting features are finally bidirectional power transfer, also known as BPT, which is enabling vehicle to home, vehicle to building, vehicle to grid services, where you can actually turn your car in a battery on wheels, so to say. So I think that is probably the most awaited feature of ISO 15118-20. Next, wireless power transfer, which enables probably the smoothest possible charging experience of all. So you don't plug in a charging cable, but you have a primary coil installed in the ground on the street, and then a secondary coil installed in the underbody of the vehicle, and through a magnetic energy field you have power transfer. Pretty cool. We will see how much that will be implemented in the market. Thirdly, automated connection device. This is basically the idea that you have a similar experience from when it comes to user experience, like wireless power transfer. So you don't need to plug in a cable, but there is there's a device that is plugging automatically towards or connecting towards the vehicle. The first use case of automated connection device is pantograph charging for buses. And there is also other use cases which we can talk about if you're interested in the Q&A session. But pantograph charging for buses is another very much awaited feature of Dash 20. Then we have the dynamic mode. This is quite interesting when you want to provide fast responding grid services, because here the idea is that you don't try to negotiate a charging schedule with the electric vehicle, but the charging station is very much in control of the charging process and telling the vehicle when to change the charging, when to change the power at each and every predefined set point, so to say. So the vehicle becomes more of a slave to the charging station, so to say. Stronger data security. I mean, TLS 1.2 was established a long while ago. It's time to upgrade to TLS 1.3. Alongside that, we have new cipher suits, meaning new, more secure cryptographic algorithms that will come into place for Dash 20 with longer keys, which has an effect on embedded devices, which are often resource constrained. So keep that in mind. And last but not least, an easier multi-contract handling, meaning think about a scenario where you want to charge for free at your employer's workplace, but maybe you have a different charging contract or different tariff when you go when you connect your car to a public charging station, and maybe even a completely different tariff when you are connecting to your private wall box in your garage. So maybe you want to have 2 or 3 different options to select which tariff you want to use to charge your vehicle. And this is explicitly enabled now in Dash 20. In theory, also possible in Dash 2, but it was not explicitly defined how to do it, and it's more explicitly explained and defined so in Dash 20. All right, so these are the main features of Dash 20. And I would like to know from you guys, which of these features do you think are the ones that are most interesting for this industry? So there is a poll, which I would like to activate now. Here it is. Do you all see the poll now? When you click on the poll next to the chat box? Yes. I would like to know from you, which feature of ISO 15118-20 is of most interest to you? Is it plug and charge? Is it the stronger data security? Is it bidirectional charging for vehicle to home, vehicle to building, vehicle to grid scenarios? Is it wireless charging, or is it pantograph charging for electric buses? We see a strong tendency towards bidirectional charging. I hope I didn't spoil that that vote with my comments, but it seems that so far the strongest vote. I'll give it a few more seconds. All right, I see a few people haven't voted yet, so feel free to choose one of the options. Give you 10 more seconds. I also see some comments, bidirectional and wireless. I do believe that is not specified in Dash 20 yet, but is easily upgradable with a new version of Dash 20, so to say, whatever that standard will be. Okay. I didn't include dynamic mode. Didn't want to overwhelm the options here. So we have a clear winner for bidirectional charging, followed then by plug and charge. No one seems to be interested in wireless charging. That's quite interesting. And a few are interested in bus pantograph charging, which is natural because the market for electric cars is still bigger than for electric trucks. But I do think this will pick up, or electric buses will pick up a lot in the near future. Thanks. Good. So back to the presentation. Let me focus on. Did I stop sharing? Wait a second. Unfocus screen here. Cool. So give me 1 second to focus on the slides again. Oh yeah, the animation. So now I would like to hand over to André to tell you a bit more about how we can actually enable those vehicle-to-grid or vehicle-to-home scenarios given the new feature in -20. André, the stage is yours.
Thank you so much, Marc. Yeah, interesting to see that the feature that everyone is asking for is bidirectional. So good that we have here a few slides that focus on that. As you see here, we have a table showing the different services that are offered in -2. So quite limited number of service, the AC/DC charging, which is the required one to perform any charging with Hubject 11.8. The certificate, internet access that is used with VAS service and use case information service as well. So with -20, you can see now on the table on your right, you have a few more offers than just the AC/DC charging. Now, AC and DC are separate. We have wireless power transfer. We have DC with automated connection device pantograph. We have AC with bidirectional, DC with bidirectional as well, and DC bidirectional, but with the pantograph connection. So it's a more broad range of service that we had before. Internet is still offered for VAS, and we also have a service for parking that is used to detect if the car or your vehicle is positioning the right setup for charging. Thank you, Marc. So as I said, we want to focus a bit on the bidirectional one. -20 introduces much more parameters than -2 adds. They are broadly the same across all the service, but there are a few differences. Here we decided to focus on the AC BPT service one. As you see, we have the connector that you can set as a single phase or 3-phase, and the control mode, scheduled or dynamic. It's important to understand the difference between scheduled and dynamic. The scheduled service is the one that resembles most with the -2. So basically the vehicle selects profile based on the limits of the station and follows that profile. And on the dynamic one is when there is an external party that sets the settings for the power transfer. So then you can have the setup like you have with AC, with dynamic, which means that the charge point operator may want to set the targets. And in that scenario, since the power electronics sits on the vehicle, so it's an onboard, it's still the vehicle that is managing it. Therefore, the targets are coming from the station side to the vehicle. Something that is different when we are in DC, where we have an off-board power electronics, which usually sits in the charging station. And in that sense, the vehicle doesn't need to provide the present active power or the current, as it's the station that defines those settings and can control the power electronics. So then we have the EVSE nominal voltage, the mobility needs mode. This parameter relates to the control mode one. So if it's mode 2 is selected, then that relates to dynamic one, which means there is a third party that provides the mobility needs for the charging. We have pricing, and we have the bidirectional power transfer channel. Here means that you either have in your EVSE a specific two, in this case, two channels, one for charging, another one for discharging in your power transfer, or you have just one specific path that is used for both charging and discharging. And then you have generator mode, so the grid following and grid forming. Grid forming is what is called as well the microgrid. So basically, the setup with vehicle and station act as generator that provides frequency, that sets the frequency of the grid and the voltage of the grid. Whilst in the grid following, it's just another load in the grid, and has to follow the setup that the microgrid has, with the usually 50 hertz frequency in Europe and the 230 volts. So it's basically just a follower there, a node. And last parameter is related to the grid code islanding, which is basically a way to detect if the vehicle station are acting as an island, so as a generator, or not. So as it can be important for security reasons, as if the station acts as islanding, then it may want to break the connection, as it may cause disruptions if it not. So there's this detection mode. Marc, you can.
One thing I would like to add on the pricing side of things. In -2, we only had abstract price levels, kind of like an indicator to the vehicle which time slots are more expensive than others, without giving a specific price. So it's a bit of a fuzzy indication, but especially driven by regulations in California, where the user needs to know the price before starting the charging process. There was the need to introduce real prices. That's what absolute pricing is about. So you have all kinds of parameters you can set, such as what is the session fee, what is the energy price for the kilowatt hour. You can set power peak prices, like power ranges. It's 20 cent bit up to 50 kilowatts. It's 40 cent up to 150 kilowatts, and so on. And also tax rules. So this is very powerful. Let's see to which degree this will be used. All right.
Thank you. One final remark about the settings of perimeters. Every kind of combination is a perimeter ID. So we can have single phase with scheduled, with no pricing, which is a set of parameters, and you can have another one, which is 3-phase, dynamic, and with absolute pricing. So there's a lot of options. There's a lot of possible combinations. So we want to give awareness to that. Go ahead, Marc. Thanks. So to have a brief overview of the message, this entitles, for example, for the bidirectional power transfer. We have here this slide that contains on the right side the charge loop request control for the scheduled modes, and on the left side is the result. As you see, there are a lot more than the charging status that we used to have in the -2. In the requests, there were nothing, and now we have a lot of different fields. They are optional, most of them, except the present active power. As I said, in the scheduled mode, the profile is known, and the vehicle is the one that sets its own power, so with the onboard, and therefore there's no need to provide any other external parameters. That's why these ones are optional. The same with the station. So in the charge loop results, the station can provide the present active power for the different phases and the targets, but as the schedule is defined and it's the vehicle that controls it, those elements are optional. In the yellow boxes, these are the parameters also used in the normal direction, so in the charging, so not bidirectional. While in the bidirectional, there is an extension in the requests. So it's indicated on the right side of the picture. You have a few more parameters that respects to the discharge, so the maximum discharge power in total and across the different phases.
Thanks a lot, André. That was very insightful. Probably a bit heavy for some who don't, who have never dealt with 5011.8-2. But if you have specific questions on this, again, feel free to post them in the box specifically for the questions.
Thank you. And yes, please ask away. We are here to answer, to help you out. I'll pass my baton to Shalin. He will give you an introduction, more insights about EXI, which is also a very interesting topic. So Shalin, the stage is yours.
Okay, thank you, Andre. So far we have seen all the new features introduced in 15.11.8-20. Now, in order to implement all these things, the messages are XML based. The specification comes with the schema files that you see on screen to make sure every message you build is compliant. So what we have on the right side is a sample XML from authorization setup response. So the XSTs here are segregated based on functionality. So common messages deals with session setup, identification, authorization, and authentication. Whereas the other ones, AC, DC, ACDP, and WPT are more function specific. So depending on which feature you want, you can pick and choose. You can pick and implement from the XSTs, and common types are common to all the above XST files. XML, DSIG, CoreSIG schema, and CI app protocol. They stay the same as in -2. So there is a trouble with XML.
One thing, if I may just add on this one, because that's quite interesting. Unfortunately, the -20 is not backwards compatible to -2, simply because the XML or the XST schema files are different. But from -20 on, all future versions of -20 will be backwards compatible, because we have restructured how these XML schema files are created. So for example, if we wanted to add another ACD service for ACD underbody or ACD side body, as they have already been discussed, we just need to add another XST schema file that would then have the name VTG_CI_ACDS for side body or U for underbody, and this would still then remain compatible to -20. Okay, sorry for that interruption.
Oh no, thank you, Marc. So yeah, that brings me to my next point. So even if you have an existing XI codec for -2, unfortunately, we bring bad news. That's not backwards compatible, because this is because of the nature of XI, the way it works, because it depends on the XST. Even if there is a very minor change in the XST, you have to generate the rules by which XI works. Now, why do we need XI? Now, as you can see on the right, the XML message you see there is quite big. It's 769 bytes, as I see it from here. Now, that is quite resource hungry. So XML needs all sorts of resources. It wants memory, it wants bandwidth, power, and eventually it needs battery. So that is where XI comes in. XI is a way to binarize an XML. It compresses it in the process. Now, how does it do it? It makes use of something called XI grammar. Now, the way XI grammar is generated is by you have something called an XI processor. To that, you feed an XST file. And once it crunches on the XST file, it understands the structure of it. Once the grammar is understood, and if you feed in an XML message which is compliant with any of the schemas, it can churn out the binary stream. Now, to explain how XI works within 10 minutes is quite tricky. However,
that's why he's our wizard. He can do it.
However, what we would like to do here, at least on the slide, is to show you what it is capable of. So you can see it has compressed 769 to roughly 38 bytes. So that's like 1/20th of the size almost. So yeah, so that is embedded friendly in some sense. Yeah. Okay, now how did we go about supporting XI codec for -20. We started with Xefficient. There are a few open source XI engines out there, but we trust Xefficient because we have been, as far as we are concerned, we have battle tested Xefficient. The first time we used Xefficient was back in 2015 when Marc open sourced Rise V2G, which is the first fully featured implementation of 15.11.8-2. So since then, it has never failed us. And we treat Xefficient like the gold standard for XI. So the obvious thing to do was to try and support -20 with Xefficient. After doing that, we stripped out the non-essentials. Now, one thing to remember is that Xefficient is a fully featured open source XI engine. It was not built with 15.11.8 in mind. XI comes in various flavors with lots of other bells and whistles. But what is interesting in 15.11.8-2 or -20 is a very specific flavor of it. So we stripped out everything that was not required. And even at the end of it, we were still left with a jar file, which is like 13 MB. And in embedded world, that is a bit frowned upon. And also there was this additional requirement of getting a JVM to run on a charging station. And that was a no-go for some of our customers. Now, the other trouble with XI is the difficulty in debugging these things. So what you see is a corrupt XI stream. So all you get is bytes, as I said, and the error message is not useful at all. Now, I've spent hours tracing one bit of information. So I understand your pain if there are XI developers out there. So this is the smallest XI message I could find. This is the support app protocol response message. The error in this is just that C0 should have been 40 or something. Yeah. Now, this brings us to our own homegrown XI codec, which was developed with just 15.11.8-2-20 in mind. So this is a high-performant XI engine. This is written from scratch. And the hardware and software requirements are quite low for this. What this means is that we can cater for a wider range of hardware. More importantly, lower spec hardware. So that drives down cost as a result. And yeah, to help the community, we provide much better and comprehensive debug messages. So what you see below that is the same XI codec, but this is what you would get if you feed this into our XI engine. Mm-hmm. Now, there is the debugging side. There is one more important point here. So Marc mentioned about Joseph earlier. Did we mention Joseph today?
Briefly, yeah.
Yeah. So Joseph is our operating system which runs on our charging stations. We also have another our CSM, a cloud-based CSMS called Sarah. So if Sarah is talking to a charging station that runs Joseph, you're not just limited to debugging the charging station. You can go through the charging station onto a charging session. So with this, you can visualize every packet that was ever exchanged between the car and the charging station. And we can do that remotely on any charging station around the world. And I think that we think that adds tremendous value. Yeah.
Indeed, that's a good point. We gave in our first episode of our Switch to Clarity webinar series a brief sneak peek into Sarah, especially around how we implemented a device model. But this is another, I would say, killer feature of our application, Sarah, to really visualize in a very user-friendly way all the messages between the car and the vehicle, or not just between the vehicle and the charging station, and not just between the charging station and the backend system. And we will have probably another session in the near future where we will showcase this.
So this slide, what we see here on this table, the messages listed are taken from a -20 AC plug-in charge session. We have listed them in sequence. In the second column here, those are the XML in bytes, the size of the XML. And on the third column, it's the corresponding XI, so you can see the kind of compression it achieves. So this is also an indication of how much information is packed into an XI. So you can imagine every bit is important in XI. It also adds to the complexity that debugging it is a pain. Yeah. So XI, and then we have the encoding time by X efficient, which is and in the last the encoding time taken by Rust XI.
And note that the encoding time for X efficient is given in milliseconds, whereas the Rust XI codec from our side is given in microseconds. So there's a huge difference there.
Yeah.
All right.
Yeah.
That's it so far, right? Okay, perfect. Thanks a lot, Shalin. I would then hand it over to Steffen, who is our expert on the search side, on the object side, sorry.
Yeah, so I have the honor to explain on a high level the changes for plug-in charge in the -20. So as we see currently a lot of interest in plug-in charge with the -2, and we have a lot of projects currently going on. We also get the question, what are the changes in the -20? So as the FDIS of the -20 came out like a couple of weeks ago, I think it's a good start to make a high-level comparison. And as Marc raised it, the -2 took 7 years or 8 years to kick off. So now we need to find early the requirements, what is important to change or to adapt also to the -20 and see which benefits do we have. On a high level, I stated here the big differences between the two norms for plug-in charge in general. So on the one side, we have the TLS, which is optional for the -2. That means just if you want to do plug-in charge, you need to do it. For the other messages or for the other use cases, it was not mandatory. This changes now for the -20. And before it was a normal TLS, so the EV trusted the EVC, but now it's mutual TLS. So the charging station has also the possibility to validate the vehicle certificate, which brings also the kind of the demand that the charging station needs to do something more. They need to know the OEM routes as well. From the cryptologic point of view, the -2 was pretty strict in the agility. So there was one cipher suit, so it was limited on one, the elliptic curve one, and on the -20 it got increased. So there are options. So that means if one of the cipher suits maybe gets not that secure in the future, we still can use the other one and vice versa. But it brings some complexity with it because now there are multiple possible. So all the end entities needs to be aware that multiple cipher suits and cryptologic algorithms are possible. For the biggest thing, which people are always asking, like, oh, cool, multi-contract handling is finally possible, which is true, but we also can do multi-contract handling today, but just if the car offers like an online installation, a telematic way of installation of contracts. But with the -20, it's now possible to install also multiple contracts over the charge point, over the cable. And it's kind of sophisticated, so the charge point can hand over multiple, which are getting sent from a plug-in charge ecosystem, and the car can say, hey, I want 10, or I want to have 10, but 5 are already reserved. So there's some certain logic which a vehicle can do now with the charging station to get more contracts over the charge point. But as mentioned, multi-contract is also possible with current implementations. Like VW yesterday announced that they will have a plug-in charge for the ID series, and they do also multi-contract handling. So you can have multiple contracts for your EV, and you can change it, but you just have one contract inside the vehicle. So this is the trick we can do today already with the current version. What's also important, the PKIs changed, so the requirements for the PKIs got a little bit extended. That means the certificates are getting bigger. Before, they were limited to 800 bytes, which was already kind of tight. So everyone needs to take care that we did not write too many things into the certificates. But now the size got increased to 1,600 bytes, and so for the chain, 6,400. So it has some implications on memory in the EV and the charge point. For the one big thing, which is comes more from the political side, how to enable multiple routes in the market. So a lot of people were talking about cross signing of routes, which is a possibility. But unfortunately, in the -2, this was not natively included. This is included now in the -20. That means routes can trust each other. So at the end, we don't have to add too many routes into EVs and charging stations and so on. So it can get easier because these routes can cross-sign each other. And so you can live in your one world, but you also accept the other route world, which is a great thing. And which has also an implication on the last one. So currently we have a maximum of 4 levels of certificate chain. So you have a leaf certificate, which is the end entity for an EV or for a charge point. Then you can have 2, minimum 1 or maximum 2 sub-layers, and then you have a route, which is still the case in the -20. But if there's a cross certificate on top, there could be a 5th level here. Marc, can you switch on the next slide? Perfect. Thank you very much. So what does it mean for your implementation? So for all, you need to take care on the encryption part. There are larger keys, the higher agility. There's a TLS 1.3 if you want to add to your -2 implementation, also -20 implementation. For the OEM, you need to reserve memory in your EVCC for all the new and bigger certificates. The mutual TLS you need to do with the EV, with the charger, EV to charger. The multi-contract handling over the power line communication, but you don't have to do it. If you already have an implementation over the telematic, you don't have to implement this. But if you have if you want to have an installation of the charge point, you have now the possibility to do this over the -20. There's a TPM 2.0 possibility, so that helps to get even a higher security standard in exchanging information. But this is going pretty deep. So let me know if you want to know more about that. For the EVSE and CPO, vice versa to the vehicle, you have to have a mutual TLS. So you need to download also the OEM routes for the OEMs, but this is already possible today with the ecosystem. So from our route pool, for example, you can download all OEM routes. So this is not a big hurdle, but the implementation for your controller needs to be ready for having a mutual TLS. And if you want to support the 2 ISO versions, which is most likely the case, because now we have -2, all OEMs are implementing it. So this will live for a while. So most likely you will have the -2 and the -20. You most likely will have also you need to have multiple EVSE leaves. One is ready for the -2 version and one is ready for the -20 version. So here's some complexity kicking in. Marc?
Yeah, just one thing I forgot to actually include, kind of a legend, because I realize not everyone is familiar with the terms in our industry. Let me give you a very quick run through. When we talk about OEM, we actually mean the car manufacturer.
Sorry.
No worries. So the car manufacturer is the OEM in the ISO 15118 world. The EVCC is the communication controller inside the vehicle, so the EV communication controller, where the 15118 implementation sits on it, and the counterpart on the charging station is the SECC. And last but not least, MO is the mobility operator. Synonyms for that is mobility service provider or e-mobility service provider. These may be a bit more common in the industry than
MSP, EMSP. It's all the same at the end.
Exactly. Yeah. All right.
Yeah, and last sentence was for the MO. Actually, for the MO, if you have an own PKI, you need to take care of the certificate profiles and PKI. If you don't, like a lot of MSPs, what we have in our portfolio, they don't do certificate handling at all. They use our service, so then they don't have to change actually so much, or because they are not touching ISO and they're not touching PKIs. But if you have an own PKI, you need to change. And of course, we or other ecosystem operators in the future, but we need to adapt our system. So we need to add the 15118-20 capability in our ecosystem. And I will explain a little bit later in the our OPCP protocol. Now, next slide.
All right.
Yes. Yeah. Which brought us to the next point. So the ISO is just a communication.
Sorry for that.
That's right. The ISO is just a communication between the car and the charging station. But there's also the VDE application guide, which explains where does the contract comes from, who is sending it to whom, where does it get stored. So how are all the players are connected. And this brought Hubject to the position that we set up an ecosystem where the OEM gets connected, the MSP and the CPO, everyone independent, so they don't have to talk to each other, but it's working. And we got a lot of questions from the market, like if someone else wants to do this, how to do it, which interfaces should they use? So we came to the conclusion it's the best that we publish our APIs with an extended version to freely available to the market, so that other parties can either implement their own ecosystems or that the interfaces are clear and defined. I think we all learned in the roaming world that there are so many, or there were so many, and there's still some roaming protocols, and it's complicated for the players. And at least here we wanted to have a start fresh, so that we maybe have a joint standard API which we all can use. Yeah, we are happy if more people can join, and maybe if you go to the next slide, I can explain what's included. So what we did is here again are some acronyms. We have an independent service operation. So if you want to operate a vehicle pool or a contract pool or different services of this plug and charge world, you can do this, but you can also operate all of them. So for example, we are operating all of them in separate services, but they're communicating to each other. And you can decide if you also want to do the same, or if you just want to operate a contract pool, for example. What we also added, because it's not written somewhere, how do player who want to connect to these systems authenticate? So how is it done securely? So we gave an impression of what's possible and what is, from our opinion, a good state-of-the-art approach. We have a role-specific authentication, so OEMs, CPOs, and MSPs. They have certain rights, but of course they cannot see each other's data. This is really impossible, so really important, and needed for the GDPR right. The system is already able to have multiple contracts. I already stated this. So for one vehicle, for one PCID vehicle identification, you can have multiple contracts. These are the emites. What we also added, which is also not defined, like it's the event service. So if something happens in the system, we are informing all needed players. So if a car gets destroyed and the vehicle certificate is getting deleted, we're going to inform all mobility operator about it, so they know what to show to the end customer that something happened with the vehicle. And the most important thing I would say is the interoperability between ecosystems. So we are currently in projects with some other players to show that interop is needed and possible. And here we hope that we can use this protocol, that we even can establish interop between these ecosystems, so that, for example, the CPO doesn't need to connect to multiple plug and charge ecosystems. So they are just connected to one, and they are communicating to each other. So it's much easier for you as an end customer, as a B2B partner, that you don't have to do this connection to everyone. The multi-route capability is there. So if there are multiple V2G routes, if it's a -20 or -2, it's possible to maintain the data. And the pool collaboration, it's kind of part of the interop part. And we already reserved some namespaces and possibilities to add the -20. So we will extend the OPCP in the near future by the needed calls for the -20, that we can handle the higher crypto eligibility and multiple contracts for the offline installation. Everything is freely available over GitHub. It's a free license, you can use it. And if you have comments, if you want to have changes, just use the standard GitHub way and ask for a pull request, and we will take a look.
Okay, perfect. We are already quite over time, but I will extend this webinar a little bit, maybe about 10-15 minutes, to allow people to pose the questions, and we can answer these questions. But it is a very complicated topic, and it's hard to put everything in 1 hour. So if you could maybe just limit it to 2 minutes or so.
I will make it fast. So this is just a picture how this is connected. Like all players in the ecosystem are independent. Plug and charge is not connected to roaming. It's also a myth that you need to use like Hubject plug and charge and Hubject roaming. No, it's not the case. You can do plug and charge on one side. It's authentication, and on the other side, it's authorization. You can use OCPI, whatever protocols. And on the last slide, I just wanted to make it easier for if you are planning to do an implementation. What you need in general are certificates, right? And so you don't have to set it up on your own. We are currently working on setting up a free V2G root for everyone. It's also publicly available. You can even create certificates from it. And we are planning this in the next quarter. And just follow us, and then you will get access to it. Will be freely available, which is already today the case for the -2. So we have already an open plug and charge ecosystem where you can connect, you can play around as CPO and MSP, create contracts, generate certificates, and just go on this website and you can play around and test your implementations. And in the future, there will be also the -20 adaptation of the ecosystem and also the -20 certificate gateway to get certificates.
Perfect. Thanks a lot, Steffen. That was really, really good, and I'm sure very interesting for a lot of our viewers. Let me go to our second poll. So let me just focus. So I would like to know from you, by when do you expect first products featuring the new ISO 15118-20 protocol to come into the market? By cars, charging stations. Is it within the next 2 years? Will it take 3 years? Or do you think way more than 3 years? Okay. The majority tends to think within the next 2 years. Some think it may take longer. While you're still voting, there is an article we published on our website on the news section, switch-ev.com / I think news and events, where I published an article on the 4 key ingredients for a thriving e-mobility market. And I linked a very interesting, or actually 2 interesting videos from Robert Llewellyn's, I hope I pronounce it right, fully charged video, where he also showed or showcased the Utrecht installation where they have vehicles with an early implementation of ISO 15118-20. I believe it's Renault Zoes. I believe I also saw a Hyundai Ioniq 5. And within the video, he said that they are expecting these vehicles first to come to market within the next 2 years, so by 2024, and that kind of matches what the audience here is expecting as well. I personally know that a few years back, a guy from Renault told me that they plan to bring their Renault cars with -20 to market with bidirectional charging by 2024. So I hope that will become reality. All right. So it seems the majority things 69% within the next 2 years. That's very encouraging as compared to -2, which took 7 years to be picked up. But also due to the fact that the EV market itself was not mature for many years until now. And just 10% think it takes more than 3 years. So let's see. I'm pretty confident we will see at least the first cars and charging stations by 2024. All right. So the last thing before we go into the Q&A session that I wanted to share with you is what Switch is bringing to the game. As I mentioned earlier, we have our own operating system for EV chargers, for both AC charging stations and CCS-based DC charging stations. And we see ourselves as enablers in the sense that It doesn't make sense for every charging station manufacturer, who usually does not have a big deal of an IT expertise, to try to reinvent the wheel and implement the standard over and over again, leading to interoperability issues as we see it very often in the market. So why not build on a bulletproof foundation that you can trust upon, that implements and tests all the ISO 15118 and also OCPP standards, and you can build your value-added solution on top that makes you as a charge point manufacturer different from the rest. That's our promise to the industry. The way we do it, we have a microservice-based approach where we have the communication stack that deals with the communication with the vehicle. You see here on the left-hand side of the graphic that deals with ISO 15118-2, -20, -3, and our own EXI codec that Shalin was presenting to you. And we are communicating with our own OCPP 2.0.1 communication stack via MQTT, the same way as we are communicating with the charging station manufacturer's own software that they need to control the hardware, and maybe they have their own additional software package for any great software feature. So we are very flexible. We can integrate very easily using this MQTT protocol, which is a very lightweight and proven protocol that has been in the industry for many decades. Now, we believe strongly that the only way to solve these interoperability issues, especially between vehicles and charging stations, is by providing an open source solution that everyone has access to, that is very well tested, basically kind of a reference implementation that becomes a gold standard. Something that I have been trying to do with Rise V2G when I first published my Java implementation back in 2015, but that was never intended to be in production use in any embedded controller. But at Switch, we put a lot of resources into making sure it's as efficient as possible and as bulletproof tested as possible. And we want to make our ISO 15118 code open source, and it will be open source very soon, probably by the end of April or beginning of May, not next year, but this year. So it's just 1 month away. And I really hope that we have a lot of people who would be interested in it to test it, to maybe uncover any open issues that we haven't seen so far. And we will make sure that we'll take this code to every jar in Testival. We take it to every conformance testing opportunity. So that is our promise and our, so to say, contribution to the e-mobility industry. That being said, I would like to open the Q&A session. So let me see what Adam has been looking at. How is it looking? Oh, I see 14 questions already. That's a lot.
Yeah, quite a lot of questions, which is great. And I saw, Andre, you've already answered a few, which we can cover off as well. So I'll go with the top ones that's got the most votes. So is there an up-to-date database of vehicles that support ISO 15118, including -20?
Let me handle that one, but maybe also Steffen can continue in that. An up-to-date database of vehicles that support 15118 or -2 and -20, no, there isn't. I mean, when it comes to when does an OEM bring out a feature that is like protected as a state secret? So it's hard to get this information often from the car manufacturers. You will know it once they put a PR statement out there. Just from talking to your industry peers, you know, or you get the feeling from when some vehicle manufacturers will bring these features to market. But the only thing I can say now is we have confirmed Porsche Taycan, at least for -2. We have Audi e-tron, we have Mercedes, I think the EQC, the EQS when it comes to market. Rivian announced, I'm not sure when they will have it really in the market. Lucid announced it, they will support it. Renault for sure, Hyundai, Kia, and they may have even forgotten a few.
VW.
Of course, VW for sure.
Skoda, Seat. So like there's a bunch of lists and more are coming. So and you just said it. The ISO just got released. So we had like the topic of -20 with all the OEMs in our projects already on our plate, but as the requirements were not fixed, the OEMs could not kind of include them now. And everyone whoever was involved in the implementation of a car, it's a long process. So if we have today a requirement to bring this now to the car, it mostly takes 2 years minimum. So we see this. We don't have a list yet who has it, or like we have a list. It's 0. But we can make a list hopefully soon with some announcement of the OEMs who wants to do it in which time frame.
Perfect. Thank you. Next question.
Okay, so André, I know you've already answered this one, but might be worth us just giving a quick overview for everyone else. So a question from Akshay. So for EV makers in the market, would it be possible to implement ISO 15118-20 at least BPT without changing existing charger hardware?
So yeah, as I wrote down, there may be some resources that need to be upgraded on the EV side, possibly also the VSC side, mostly with the controller that handles the communication. As for example, certificates there are more certificates, so maybe more disk space is required. Also, we are handling another set of message, another protocol. There's a different state machine, so it means more code. So maybe more processing power in that sense. But in terms of power electronics, as far as I know, most of the OEMs already provide a hardware prepared for bidirectional power transfer. The only question is more for the AC side on the vehicles, on the onboard system, but it's something that is easily, that can be upgraded to bidirectional, and on the station side, the same. And as of my knowledge, most of the OEMs already prepared for this situation, so it's more like a software question over than hardware.
But sometimes you have to keep in mind the HSMs. Like if an EV already has an HSM, why should they put like a higher HSM today in the cars? It's expensive. Like if it costs €1 more and VW will add €1 for 1 million cars, like it's a lot of money. So this is like why the OEMs like a horse. You just have to jump as high as you need, because it will add a lot of resources later on. So hardware and software, I think, so most likely no implementation today is ready for the Dash 20, I assume.
And can you quickly explain what an HSM is and how does it compare to a TPM?
Yeah, so like at least for the HSM, so like the hardware security module, it's important that the PKI, it's a matter of trust. So it's a key material like private keys and public keys, and you need to store them securely in the charging point, but also in the EV. Because if you take them out and if someone could steal them, they could pretend to be the EV or to be the charging station. This is not good. And this is like an HSM is a closed environment, a chip where the certificates are getting stored. And if someone wants to breach into it, like software-wise, but also hardware-wise, it will destroy itself or it will lock it down. So it's special devices to secure the key material. And this is really like, it's pretty expensive, like even bytes. Like before I wrote down like 800 bytes. So some people would like, it's a joke, right? But for HSM, it's money. And no one wants to add too much money into EVs today, right? Well, always, because it's volume market. And the TPM is just a variant of the HSM, which can be done a little bit cheaper maybe, but this could be included the whole certificate for later on, but it's a different story.
Perfect. Thanks for the explanation.
Yeah, sure.
By the way, I also forgot to mention Ford Mustang Mach-E for the cars that are supporting Dash 2. Thanks, Alex, for mentioning that. Right. Next question.
Okay, so we had a question from Stefan earlier in the webinar regarding the open source of Joseph, which I think we've already covered off in your update, Mark. But Stefan, if there's any more questions on that, just let us know and we can cover that off. So just
okay, just to mention, it will be a license. We're still looking into it, specifically which license. It might be MIT, but maybe more likely an Apache license version 2. So not a copyleft license, but one license that can be used commercially, because that's, of course, what we want to achieve with that. And yeah, you will very likely with our next webinar get more information about OpenJoseph.
Great. Thanks, Mark. Then we've got a question from Vina. So is there any plan to extend bidirectional charging to VTL and V2H and V2V?
So V2V, so vehicle, or V2 load. V2L means vehicle to load, and V2V means vehicle to
load.
And V2V is vehicle to vehicle. So far, I don't know. I haven't heard of any plan to extend it to that specifically. I mean, vehicle to home is of course already possible. It's just, bidirectional. It's just reversing the power transfer from the vehicle to the charging station. Whether it goes into a home or beyond the meter into the energy grid is then a matter of can you feed in energy into the grid, complying with what is called a grid code. So regulations that define how you feed in energy into the grid to not destabilize the grid. That is a very hot and delicate topic. But vehicle to home, definitely possible. Vehicle to load, vehicle to vehicle, not.
Vehicle to load also would be, it's similar to vehicle to home. So as long as you have a management system that handles what the load wants, and you can control the station and provide that to the load. Now the vehicle to vehicle, it's a bit more interesting. What exactly does that mean? It'd be a direct connection between vehicle and vehicle with charging station is in the middle. I think that would be the scenario without the charging station in the middle. But I think that is a bit more fuzzy topic, at least for me.
Yeah, perfect. Thank you for that.
Okay, thanks both. So just moving on. So we've got a question from Tim regarding ISO 15118-20. So does ISO 15118-20 enable V2G for street charging, and will it seamlessly identify the owner of the power via plug and charge?
I mean, whether it's street charging or wherever you charge, that's just a matter of where the charging station is located. And will it seamlessly identify the owner of the power via plug and charge?
Also, I'm not sure what he means, but at the end, the contract certificate, which is sent to the EV, to the EVSE, to the charging station, identifies the contract, not really an owner. It could be a fleet use case, right, where the driver doesn't know actually about it; it's just paid. But at the end, the charge point identifies the contract, and so the CPO MSP can identify the person or the entity who's paying for it. So maybe you want to combine it with your local, maybe energy supplier, who also like that you have a local energy supplier which is also enabling you for charging your car.
Tim, would you want us to invite you on screen so you can elaborate your question? Just post in the chat box, and if so, I can invite you on screen. If not, then we would just continue with the next question.
Okay.
Don't see him. Okay, maybe you can pick this up later.
Yeah.
Right.
No worries. Perfect. So then we've got another question regarding the pricing, which is early on in the webinar. So which side should present the pricing information to the user before the charge begins, the EVCC or the SECC?
Yeah, that's a good question. I mean, that is completely out of scope of ISO 15118. That standard just provides information. Whatever you do, it is up to the manufacturer, right? I personally, I am not sure if it makes too much sense to provide this information. Maybe there may be a use case. Imagine you plug in your cable, and then of course you want to see the information about the price on the charger display. You don't go into your car to look up the pricing information, right? But maybe later on in your car, you want maybe to see an overview of your past charging events. You want to know how much each charging event costs. What's the past term of cost anyway?
The question also that brings is how long do we have to choose the profile if that appears, and when you connect the vehicle and then the session starts, or should the session not start and you have to choose a profile that is presented before anything starts. So it's also directly a little question there, I suppose.
And some also want to know the pricing before they want to start, right? So you like one contract is active, and you're going to a charging station, and you want to know before you go out of the car the pricing. So both is needed and nice, but it's kind of complicated to implement this because like bringing all the information to the different stakeholders, it's complicated because a lot of each TPO, each MSP have different pricings. So to make this transparent to the user, it's kind of complicated.
I mean, one thing to note is ISO 15118 has lots of sophisticated guesses or educated guesses on what you want. Keep in mind, it's an international standard. There are so many companies that want to bring in their business cases and mold them into a requirement and a message. Whether or not this will ever find its way the way it was intended to is a different thing. For example, this absolute pricing that I was briefly touching upon, where you can provide all kinds of pricing information, that is not even supported by the roaming protocol so far, like OCPI, this whole level of complexity. So these protocols need to still catch up with what has been thought of in -20. I mean, -20 still needs some time to become a product in the market, but anyway. And when it comes to selecting the contract in the car, as Sebastian just mentioned in the chat, I believe that it probably makes sense to have kind of a preset combined with maybe geolocation-based services. So the car knows if I'm in that geolocation, I use that contract certificate, and in that location, a different one. What do you think, Steffen?
Exactly. So this is also use cases which are getting implemented, also where we also do user stories. It could be time-based, it could be location-based by geolocation, especially for the fleets and commercial vehicles. You have sometimes a driver, he doesn't know about the countries he's going to, which price is best, but the fleet operator can install per country, per region, the right contract for this region. So this is really also something where we can play around with the OEMs and the MSPs, what could be the nicest and best customer experience, right? So they can set it up on their own, but it can be also automatically. And the pricing, of course, to know the pricing before to get always the cheapest contract. This is the highest bar we need to achieve, but we are, I would say, far away from this. So for now, it's I decide for my contract, I decide when and where, but based on the pricing, this is next level.
Yeah. Okay, thanks. Next one. I think we have time for maybe 2 more questions.
Okay, no worries. So we've got a question from Robin. So how difficult is it to incorporate BBT feature into the product that is defined on ISO 15118-2?
Well, let me take that one, and André, if you would like to expand, go ahead. You can. In -2, as in -20, you have the option to extend the protocol into a proprietary version, still being compliant in the end, by means of creating a specific payload type, or by creating a specific minor version, as it is called. I don't want to go into too much detail. Explained it a lot in the basic training if anyone is interested. But keep in mind that if you want this to work, the charging station and the vehicle need to both be able to understand this proprietary version of 15118-2. So it's not a solution that would work in an interoperable way, but if you're in control of the car and charging station, you can extend it and still be backward, like compliant to the standard. So there are ways to extend it if need be. Okay. Next one. Or did you want to add something? Okay.
Okay. I'll pick one that we've maybe not answered in the chat itself. So we've got one from Vina here. So if the EVSC supports only part 2 and installs a new contact certificate in EV, and this EV, when connected to the EVSC supporting only part 20 standard, will it invalidate or not accept the contract certificate saved within the EV?
Okay, that was a long question. Where?
Yeah, well, I can answer. So basically, it would be a no-go. It would be a no-go because it doesn't matter if the contract installed was -2 or -20, whatever. But if the vehicle and station both can talk the same protocol, so the same lingo, in which case is the -20, then it's a no-go. So in the very beginning, there's a supported application protocol, and the vehicle will tell, I can do -2, and then the station will answer, I can do -2 and -20. So the only common ground is -2, and -2 goes forward. If they both offer -20 and -2, the prioritized one is -20, if I'm not mistaken. So the -20 will go on, but they both need to support the same protocol in order to then do any kind of contract certificate installation.
And if the certificate got installed, so this is done, there will be the authorization also on the either higher or lower standard, right? And so it will present either the contract certificate from the with a higher cryptologic standard from -20 or with a lower one, depending which language they are talking. So if they align on -20, it needs to show the contract certificate from the higher version. If it's the lower one, it will show the lower one.
Perfect. All right. Okay. Let's do one final question, and then don't worry, we will answer all your questions, just not in this webinar. As we did with the, let me just focus. As we did with the first episode of our webinar, we will create a blog post where we will list all the questions and we will answer all the questions, including those that we couldn't attend to during the webinar. So, Adam, which one should we take?
Let's go. I forgot one from Sebastian. So, how does Open Smart Charging Protocol (OSCP) live with OCPP 2.0.1? Is it non-retro compatible or symbiotically?
Well, the Open Smart Charging Protocol, which is, I believe, a protocol used to connect the charge point operator, the CPO, with the distribution system operator to exchange grid signals. Like if there's an emergency situation, the grid and the CPO needs to downgrade the power drawn by other vehicles. So that is OSCP, Open Smart Charging Protocol. I'm not sure if that is actually really used widely. I know it's been defined, but I have not seen anyone talking about it being actually implemented. I may be wrong. So how does this live with OCPP 2.0.1? Non-retro compatible or symbiotically? I don't know of any talks between how to make 2.0.1 OCPP compatible with OSCP. Does anyone else have any other information? No? No. Okay.
No.
Good. So finally, you see or you should see a button somewhere. Or is it maybe after the presentation? I'm not sure because I don't see it on the screen. Anyway, if you would like to learn more about Joseph, how it may help you in your business, feel free to click on that button. Then you can set up a meeting with Stuart, who is heading our commercial department. And other than that, please follow us on LinkedIn, join our newsletter. What else is there to say? And stay tuned. Would love to see you again in our upcoming webinar. We will do this every month. So we started this just in February, and we want to keep the industry informed. And that's it from my side. Thanks a lot for joining, and we'll see you next month. Have a nice weekend. Bye.
Thanks for organizing.
Have a nice weekend, everyone. Thank you.
Everyone.